How has the theory of relativity influenced modern physics? How do we experience time? Do we believe that clocks move at the same rate for everyone, and that space always stays the same? But what if time moves more slowly for some of us and faster for others? Physics is largely divided into classical physics and modern physics. Classical physics explains the world we see in everyday life. A ball falls, a car moves, and even the stars move across the sky. In this world, time flows the same for all of us, and space exists like an unchanging stage. However, as we entered the 20th century, this familiar way of thinking began to change. At the center of this shift was the theory of relativity by Albert Einstein. He explained that in a world moving close to the speed of light, the laws we knew no longer apply in the same way. The theory of relativity is remarkable. In fast-moving objects, time flows more slowly, and under strong gravity, even space bends. In other words, time and space are not absolute. They are flexible, changing depending on the observer. We can also find a similar idea in our daily lives through analogy. Think about Gulliver, the main character in Gulliver's Travels. In the land of the tiny people, Gulliver appears as a giant. But in the land of giants, he becomes very small. Even size becomes relative, depending on the standard we use. The same is true for up and down. On Earth, we distinguish between up and down, but in space, that standard disappears. Astronauts simply feel that the direction they are facing is down. Ideas that once seemed obvious to us are actually all dependent on a frame of reference. This is the essence of relativity. So why is the theory of relativity so important? It is not simply because it revealed new facts. More importantly, it changed the way we understand the world. Before the theory of relativity, science was something we could grasp through intuition and experience. But it showed us a world that is not easy to accept through intuition alone. It is like leaving a familiar path and opening a completely different map. This change did not happen all at once. Scientists do not easily abandon existing theories. When the orbit of Mercury showed slight irregularities, people first tried to preserve the old theory by assuming the existence of a new planet. However, the theory of relativity explained the discrepancy precisely, and eventually, the new theory replaced the old one. In this way, the development of science is not simply about discarding what is wrong. It is closer to a process in which better explanations emerge. The theory of relativity was one such better explanation. Interestingly, modern physics is not completed by the theory of relativity alone. Another important pillar is quantum mechanics. Einstein once said, "God does not play dice with the universe," showing that he found it difficult to accept the probabilistic nature of quantum mechanics. Ironically, however, his work on the nature of light contributed greatly to its development. Now, let us return to our first question. Are the time and space we believe in truly unchanging? Or do we simply feel that they are? Relativity leaves us with an important message. Question even what seems obvious. What is something you believe is too obvious right now?